Saxon Algebra 1/2, Lesson 9. Greetings, students. We're going to talk today about some topics that are technically called geometry. This is kind of an intro to geometry, although you've done geometry in the past. Geometry has to do with the study of shapes. Oops. And the way that the Saxon curriculum works is that geometry is not a separate class, it's mingled in with all of the algebra topics, which I really like, partly because I think it's silly to pretend like it's a completely different thing, and also because it's more fun to kind of mix up the topics so that you're not doing the same thing all the time. So we're going to start talking a little bit more about geometry. Again, this is a review. It'll probably sound familiar. But we'll build on this and eventually challenge you. The beginning idea with geometry is that of a point. A point is an exact location in space. That's way too big for what a point actually is. A point you could boil down to like a little atom. It's a tiny little speck, but it represents a location in space. Whoops, I'm having a hard time with the shapes of my letters, aren't we? Location in space. Oh my gosh. Okay, good. If you put a series of points together in a perfectly straight arrangement, that's called a line. A line is infinite, and it's a set of points. If, instead of having them perfectly straight, you bend the points, that's called a curve. Okay, so far so good. If you take a curve, now a curve is infinite, right? Let me just write this. A curve is a line, an infinite set of points that bends. Now, this is the way we draw a line, right? It's a series of points that are connected. It goes infinitely that way and that way. Think about it. It goes across my dining room table, out my living room wall, across the neighborhood. That's roughly north. That's roughly south, the way it's aligned on my table. It goes off planet Earth, out into our solar system, beyond that, through the Milky Way, and across to the ends of the universe, whatever that might be, in both directions. That's kind of an amazing thing to think about. A line is a very powerful and cool thing. In fact, they're more than we can handle. So sometimes what we do is we identify one point on a line and another point on a line, and we say, we'll give them names, A and B, and we say we only want to talk about that much of the line, because to talk about the whole thing is too wild. So we call that a segment, and we write it with symbols like that. This means the segment AB, okay? If we want to talk about the whole thing, a way we can abbreviate that is the same thing, but with the arrows on there, that makes it, oh my gosh, I can't talk. That makes it a line. A segment has endpoints. What if we want to take one endpoint and one infinite end? That's called a ray. Cool, right? Now, what if we take two rays and put them together, two rays that intersect? That's one way to define an angle. Okay? A ray is sometimes called a half line, because it ends on one side, but it goes infinitely the other. This is a line segment. Okay, I'm just looking at the book to make sure I've covered everything. Yes. Okay, let's see how we can use this with some arithmetic to come up with some interesting problems. This problem has a picture for us. Yay, draw it. Please remember that it is not a waste of your time to redraw the pictures in your homework. I just did it. It's not a waste of my time because I notice things differently when I draw them. It also gives my brain a little chance to breathe in between the problems. So drawing the diagrams in your homework is an important step of beginning the problem. Please don't skip it. All right, so we have a line we see that goes infinitely, and we've identified 3 points on the line, A, B, and C. And this identifies technically 3 segments if you think about it. We can go segment AB, or we can go segment AC. Oh wait, there's even more. We can go segment BC, and we can go segment AC. Whoa, there's 4 segments built into that. Crazy, right? Okay, in this one, AB, is 3 units, and AC is 7 units. And we're supposed to find BC. Now, the first thing I notice is that John is not putting those little segment lines above the letter. However, he is using letters to identify the segment, and he's telling us how long it is, so we know that it's not the whole infinite thing. We know it has to be a segment. We can infer that, but we are not told that specifically. So we kind of have to keep our brains switched on while we're doing these. Okay, so AB is 3 units. That's this chunk, right? And AC, I'm gonna draw that underneath so I don't write all over myself. That is 7 units. We're supposed to find that chunk. Okay, well once we see it in the picture, it becomes really clear that this must be 4 because it has to add up with this other one to become 7, right? So we can say BC equals 4. If you draw the diagram, that is showing your work. You don't have to show me 7 minus 3 equals 4. This is how I know what your brain is thinking. So another reason to draw the diagrams is because it's a great way to show your answer. Okay, I want to talk a little bit more about angles. The neatest, cleanest sort of angle that we run across is what we call a right angle. It's called a right angle because its sides are perpendicular to each other and are very neat and tidy. It's the side of a square. We can also have one that's a little smaller than that. And we call that, let's see, this is called a right angle. And the word we use to describe 2 lines that come together like that is perpendicular. You're writing with me, right? Keep drawing, do it all. This is called an acute angle. Okay, it's a little bit smaller, isn't it, than a right angle. This is called an obtuse angle. It is wider than a right angle, right? The size of the angle is bigger than a right angle. With an acute angle, it's smaller than a right angle. And then usually we just think of this as a straight line, but it can also be considered an angle. It's called a straight angle. So that has a name too. We can think of it as an angle. The other thing that we can do is remember that a right angle has 90 degrees. Degrees are the tools we use it's the unit we use to measure angles. And a right angle is always exactly 90 degrees. That's how we measure this. This is less than 90 degrees. This is more than 90 degrees. A straight angle, which we can look at as 2 right angles put together back to back. Both of these are 90 degrees. Makes sense? So a straight angle is always equal to 180 degrees. We're going to talk about that a whole lot. Okay, I can compare them all. All right, good to know. Next topic, perimeter. Perimeter is the special name for what we can call length when you're measuring around a shape, right? Length is just like a straight line, but if we measure the length all the way around something, we give that the fancy name of perimeter. Here's the way. We're gonna do lots of problems with these. All right, here is a shape that I am drawing from the book, and we are told to find the perimeter of this figure. We're told that dimensions are in meters. Whenever I'm doing a geometry problem and the problem tells me the unit, I make a little note of it over to the side. I use the abbreviations because I don't want to spend my life writing out units on my page. We only need that unit for the answer. The math of doing the problem, it doesn't make any difference. But I write it down because I want to put that unit on my answer to make it proper and correct. Now, there's numbers all around this figure. I'm going to copy them. You do too. Okay, that's the way it looks in the book. What these numbers represent is the length of each side. So when we want to find the perimeter, we're adding up the length of all the sides. All right, so the only trick I would recommend to you is pick a starting place. I usually start in the bottom left, but you can start wherever you want. And all you need to do is just to keep track of where you started so that you don't go around in circles or stop too soon. So I always put a little mark there. 10 plus 7 plus 7, right? Those two are 7s. This is an 8. 17. 15. Double check it to make sure I didn't go crazy and forget anything. And all we have to do is add those up. So I'll give you a minute to add them up while I add them up, and then we'll compare notes. Okay, I came up with 64 as the total, and then I remember just to add my unit at the end. This time I'm gonna write it out. I'll write the units out until we get pretty comfortable with all the abbreviations, and then I'll stop doing it. This is the right answer. Okay, you've probably seen this before. I understand. Okay, example 9.3. Find the perimeter of this figure. All dimensions are in feet. All angles are right angles. Let me draw the picture. And then we'll talk about what that last little thing means. It's good news for you to hear that. Sometimes it seems like it's bad news in the instructions when you get all these annoying details, but that's one that's really good news. Let me go around and add the numbers. You can too. And you might notice as we're writing these that not all of these numbers, not all these sides have a number. We missed a couple. Okay, all angles are right angles. What that means is that these are perfectly straight sides and perfect corners. That's good news because it means we don't have any weird angles that we have to cope with. Everything's perfect and straight and even. So when you see that sentence, all angles are right angles, you say, thank you, John, moving on. Okay, that's just good news that it is as simple as it could be. All right, I'm gonna start here and start adding things up again. And let's see what happens. Okay, 8, 4, 6. I'm skipping lines, I don't know why. Okay, hold the bus. There's no number for this side. What are we gonna do? Well, what we do is we pull back and we take a look at this figure from a slightly bigger perspective. And what we notice is that this is the side we're missing. Well, we have this side. We know this is 14, but it's a whole lot longer than this one, right? But what we can notice is that, look, if you take this and this, if you take these three, they should add up to that, right? These are all straight corners, so we haven't lost anything there. These 3 lines should equal 14. Okay, well this is 4 and that's 2, that's 6. So if we subtract 6 from 14, that means that this side must be 8. So we can add an 8 over here. Well, shoot, we come to the next side and we go, dang it, we don't have this information either. We want this side. We don't have it. This is 8, that's too long. That's 8, but look, this is exactly the same length as the side we're interested in, and that tells us that this must be 6. Oh, these are kind of fun. You have to be like a detective. Okay, so here's another 6. Then we have 2 at the top, 8 on this side, and 14 on the bottom, and I'm back to my arrow. See, this is why you need that arrow, because we're going along, it's fine, but then suddenly you get caught up in all this drama and you're figuring other things out, and it's like, I don't even know where I started. I'm just in a daze at this point. So put some sort of little marker there so you know where you started. Okay, we're adding up. This time I'm gonna look for pairs of numbers that give me 10. 6 and 4, 6 and 4. Okay, there's 10, 20, 30, plus 16 more, that's 46. And we just have the 110 there, so that's 56. And our unit is feet. Again, that doesn't change the math at all. We just add it in at the end. Yay, that's right. Okay, so this is the game that we're playing. Our shapes are a little bit complicated, but the trickiest part is that sometimes we have to use the clues to come up with the lengths of some of these missing sides. The practice problems that you will do, let me just show you. That's the end of the lesson, by the way. Here we're just using symbols to write a line, 2 rays, and a segment. Remember that, I'll just help you with this one. This is practice A. The symbol for a line above letters is like that. The symbol for a segment is like that. And the sign for a ray would be like that. Okay? And let me just see if there are any on the other page. Yes. Draw an example of an acute angle, a right angle, an obtuse angle, and a straight angle. And we did that. It's in your notes. You're good to go. All right? You are done with lesson 9. Well, you're done with listening to me talk about it. Now you get to go and do the homework. Remember that listening to me talk about it is just the opening act. The real place where the learning happens is in your homework. Okay? So that's the important stuff. I'm just setting you up. I'm like your coach. You know what I mean? I just send you into the game to play. But working with me, this isn't the real game. The game is when you do your homework. All right, I will see you for lesson 10. Goodbye.